Hello everyone, in today's lesson, we'll be learning about FineBI's filter level. If you've been following our update logs starting from version 6.1, we have essentially redesigned the entire filtering system. This new filtering framework, or rather the rules of filter level, are actually more intuitive to learn. Regarding the target audience for this course, I'd like to emphasize just one point. You need to have a certain understanding of FineBI's calculation framework. For example, basic concepts like aggregate calculations should be familiar to you. Otherwise, the following content might be a bit challenging to follow. The main course content is divided into 3 sections. First, we'll start with the basics, where we'll briefly introduce the filtering system. The primary goal here is to help everyone develop a mindset for prioritizing filters. Then in the second section, we'll move on to more advanced topics. Here we'll explore the complete filter level, covering even the less commonly used levels to ensure a thorough understanding. The third section focuses on frequently used but often misunderstood features, such as indicator conditions, dependent dimensions, and group filtering. We'll provide a detailed explanation of these functions to make them clear and easy to apply. Alright, let's look at the first part, the initial filter level. First, I have a question for you. Why would filtering have a hierarchy? Or why does the order of filtering matter? Check out this example. On the left here, we have a detail table with regions, branches, and sales. Now, let us first apply a filter to only show sales greater than 100, right? Then we ray down to just these 3 rows. Next, we run a calculation to find the total sales each city. And finally, we get the results for Shanghai and Guangzhou. So, what did the filter do here? It basically set the boundaries for our discussion. With so much detailed data, I only want to analyze the branches with sales over 100. Everything else is filtered out. As we covered earlier, aggregation is really an analytical process. Now let's try reversing the order of these 2 steps. First, analyze the sales each city, which gives us this summary table. Then apply the filter for sales greater than 100. We get a different result from before. The most obvious difference is Beijing. Its data now appears in the results. The reason is that neither of Beijing's 2 branches had sales over 100. In the first approach, they were filtered out early, so they never made it into the calculation. But in this second approach, where we calculate first and filter later, those Beijing branches were included in the initial aggregation. So their combined result is what we see here and is what gets retained after the filter. The key takeaway is that in this second method, we are essentially filtering the final results of our query, not the raw data we start with. Through this example, you can gain an initial understanding. The sequence of filtering and computing is closely interconnected. One might even say they complement each other in terms of execution order. Let us take a look at the filtering level system in FineBI. This chart might appear complex, so let's break it down step by step. First, the data table refers to the prepared dataset we start with. Next, we have column adding through define. This essentially uses the define function to output a specific indicator. The third step is aggregation calculation. This is quite common. For example, when you drag dimensions and indicators into a grouped table, that process is essentially an aggregation calculation. After aggregation comes quick calculations. This involves functions within FineBI, such as quick ranking calculations and so on. Finally, we arrive at the resulting output. Using aggregation calculation as a dividing point, we can categorize the steps before it as the detail level and those after as the aggregate level. Correspondingly, a filter can be inserted between each of these calculation steps. Why is that? Let us recall the previous example. If we apply a detail filter to our data table, It will naturally impact the results of all subsequent calculations. To make it easier to understand, let's simplify. We'll focus only on these two layers, the detail level and the aggregate level. There's a data table. I apply a detail level filter first, then perform calculations. After the calculations, I apply another filter on the processed results. This process is quite straightforward. Let us walk through an example to see how this works step by step. We'll use the data table named Filter Level Course Data 1, which you can download from the course attachments. I encourage you to download this data table and try it out yourself in the latest FineBI 6.1 version. You can also practice directly using our online demo platform. Before we start the actual operation, let's first analyze the problem. Step 1. I need to identify all the filtering conditions. The problem description contains several key points. First, orders from April to June. This is a very common time-based filter. Second, high-value orders, since the focus is on analyzing the total sales only from high-value orders. This can be refined as orders with an amount greater than 1,000. Third, total sales greater than 250,000. Once these three filtering conditions are clear, the next step is to plan how to configure them. Let's refer to the simplified diagram. We first need to determine whether each condition involves aggregate calculation. We can see that total sales greater than 250,000 clearly requires an aggregate calculation of product sales. Because just looking at a detail level table, I can't tell the total sales of a product over the month. Next, let's decide whether each condition should be applied before or after the aggregation. Notice that the first two, April to June, and high-value orders should be applied before any calculation to define the scope of our analysis. The last one, total sales greater than 250,000, is easy to understand. If I don't first calculate each product's total sales, how can I filter for those exceeding 250,000? So this third condition acts as a result filter. Now that we've clarified the logic, let's move on to the hands-on operation.